Okay, so we just finished discovering the relationship between when we rotated a line 90 degrees and that we had that relationship of opposite reciprocal slopes, which we saw in, so here, opposite reciprocal slopes, and then here that we also had opposite reciprocal slopes with our line of reflection and our connecting lines. So we're going to play some games and see if all perpendicular slopes are related the same way. So you're going to need to, I would use 3 different colors, but if you don't have them, go ahead and use whatever you've got. So we need 3 lines, one with a slope of 1. And slope of 1 is annoying, so I'm doing a slope of 2 over 2, which is the same as 1. I'll do that one in blue. I'm going to focus on that one first. And so in blue, so there it is. And then I need another one. And so there it is. It's also going to be blue. And just like before, I'm going to use tracing paper. And in my case, I'll use this little symbol and rotate it. I'm going to rotate around the origin again. It's easiest. You can rotate around any point. It doesn't matter, but origin gives you something consistent. So I'm rotating around the origin 90 degrees. And there I am, 90 degrees. With the pad tracing paper, if you have it folded in the quadrants, and I'll show you in class before this video, but folded in the quadrants, you can actually measure 90 because you have a 90-degree fold. So let's make sure we ask each other and talk about that, or ask Ms. McFerrin for some help there. But there's my 90-degree angle, and if I put some more dots on my slope to check it, I notice that it's 2 and 2, but it's down 2. So with my slope of 1, I'm going to write this over here. My new slope after rotation is negative 2 over 2, which simplifies to negative 1. So if you recall, to get my first slope, to draw the slope, I did 2 over 2. So we can still see that reciprocal. It's hardest with 1. So there's 1. I'm going to go ahead and erase all the dots so the dots don't get in my way, but I'm going to leave the line here. All right, so let's draw another line. We'll use the slope of 1/3 this time, and we're going to go with red. So starting at the center, at the origin, it's giving me a hard time about putting a dot there. Up 1 over 3, up 1 over 3, up 1 over 3, down and left, over 3, 3, and 3. And using my tools again to draw the straight line so that I can be sure it's a straight line. It's off just a little bit, so let me get that knot off a little bit. There we go. That's pretty good. Okay, so there's my line. I'm going to duplicate it just like I've done before with the others and put it on top. So that I can rotate it. So we're going to, again, rotate our new line, not like that. I have moved the rotator. Bring the rotator back. I'm going to rotate my new line. And again, 90 degrees. That's not 90. See how it's not at a right angle? Got to keep going till I get that right angle right there. Not quite. Not quite close. There we go. Right angle. So again, we have there, 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 there. And so, oops. For my slope of 1/3, my new slope is down 3 over 1. -3 over 1. And you'll notice the same relationship. Flipped over, signs changed. Flipped over, sign changed. So we're going to move on. And again, I'm going to erase all my dots, leave my lines here. And this time, I'm going to go ahead and go with green for my line. And so this one is -3/4. So I've got down 3 over 4. Down 3 over 4. My first move was from the origin. Again, the tool in the middle is making it so I can't put a dot right there. 3 over 4. 3 over 4. So there's my line. I will again use my ruler-ish tool to make myself a straight line. Go through all the points. Okay, so there I am. And again, the other lines kind of are in the way. It's harder to see, which is why I'm trying to use the color. But we're going to go ahead and duplicate this green line and get it on top better as much as possible. So it looks like there's only one. And then we're rotating, again, 90 degrees. And there I am, 90 degrees. And let's put some dots on that. So we got one here, and one there, and one there, and one there. And we'll notice that it's 4 and 3. So my original slope was 3 over 4, was -3 over 4. And my new slope is 4 over 3. And so it's positive. So again, use tracing paper, and we've traced and we've rotated, we've determined the slopes of the new line. So we did all of that over here on the side. And how does the slope compare with the original? So now that we've done all of them, all slopes, all new slopes, and originals, slopes are opposite reciprocals, which means they're all perpendicular. And so without using the rotation, which is I've basically been doing the whole time. So let's say my original slope is 5 over 8. My perpendicular slope, I'll flip it over, so 8 over 5. And since this is positive, this will be negative. And that's all you have to do. So all you have to do is flip it over, reciprocate it, change it, and then change its sign. So if it's negative, you make it positive. If it's positive, you make it negative. And then you have opposite reciprocals. And let's see, we've got, I think, one more question. And so this one is very generally, and so now we're trying to use letters. Two lines are perpendicular when they can be rotated 90 degrees onto one another. However, a rotation does not only move all the points on the line, it moves all the points in the shapes on the graph. The axes never move. So the relationship can be demonstrated by using a non-special line along with its slope triangle. So I wasn't specific. I just drew a line and I said, hey, my slope triangle is A and B. Notice there's no grid. I have no idea what everything is. But what does this question mark have to be? Well, it was here, it was B. So now it's B. And this was A, and that's A. But this B is negative, right? It's going this way. I mean, it's going right and up. So this one's going down and right. So that's still positive. And so we can show that in this, by putting these on, that if my original slope is B over A, my perpendicular slope has to be A over, excuse me, that is wrong. I apologize for that. My original slope is A over B, sorry, rise over run. My new slope has to be negative B over A. And so if the slope is 0, and I rotate it, because I can't do 0, because 0 over 1 cannot become 1 over 0, it doesn't work. But negative 1 over 0, that's what we would do. And that's, we can't divide by 0. This is equal to 0. This is, we call it undefined. But a horizontal line, when rotated, becomes a vertical line. And they are perpendicular. So that's one of those standard things that we use all the time. So the point is that if this happens, you know that it's perpendicular. Stay tuned for the next video, and I'll give you some homework hints.